So today we will have some problems from, we'll be doing some problems from electromagnetic induction, alternating currents and magnetism and matter. Few important models wherein you can revise the formulae. So here in the given figure, current from A to B in a straight wire is decreasing. So here current is decreasing in this wire. So now this is the current carrying conductor. So when you hold this wire with your right hand, so below the wire your four fingers are curling into the board, into the plane, and after holding this wire, when you your fingers are coming outwards. So here the field is inwards and here the field is outwards. So this is outwards. Now there is a coil over here. Now in this coil, what is the direction of induced current? Now here, if this is outwards, you can imagine here, you can imagine a bar magnet like this with a south pole. Whereas if it is inwards, you imagine a bar magnet with north pole facing towards this one. Now in this is the south pole. Now current is decreasing. When the current in this wire decreases, the corresponding field produced due to wire also will decrease. So that means now the field which is present over here is decreasing. When will the field decrease? When you imagine the magnet to be moving away. So south pole is moving away this way. This south pole is moving away. So when the south pole is moving away, then according to Lenz's law, this face has to behave as a south pole in the sense clockwise. South pole is moving away. So according to Lenz's law, this pole has to attract this one. It should not allow the field to decrease. So as a result, that means the south pole is moving away. This coil has to pull the south pole towards it. That means this face has to behave as north pole in the sense anti-clockwise direction. So once again, let us just go with the explanation here. This is the current I, straight wire. As we know, due to straight wire, magnetic field is mu naught by 2 pi into I by R. So this one, P is directly proportional to I. So in this wire, as the current is decreasing, the corresponding field produced by this wire also decreases. This is the first point. Second point, the direction of field. When you hold this wire with your right hand, below the wire your fingers are going into, and above the wire fingers are coming outwards. So here, as the coil is placed here the field is outwards. B. Now third point, whenever the field is increasing or decreasing, whether the field is inwards or outwards, you imagine a bar magnet. If the field is inwards, imagine a north pole. If the field is outwards, imagine a south pole over here. So in this case, this is outwards, so you have to imagine a south pole. So this is the south pole. Field is decreasing. Here, when will the field decrease? When this point is away from the magnet. So just imagine that the south pole is moving away. Now when the south pole is moving away, field is decreasing. According to Lenz's law, current is induced in this one. What is the direction of current, induced current? It opposes the change. So here, as the south pole is moving away, this coil should not allow the south pole to move away. So this south pole is to be attracted. Which pole will attract south pole? North pole. So this face will behave as a north pole. North pole means anti-clockwise direction. So the induced current will be in the anti-clockwise direction. So here, when I decreases, the current will be in this one, is anti-clockwise direction. Opposite, if the current is increasing, then the field also will increase. Then the field increasing means the magnet is moving towards. So south pole is moving towards. When south pole moves towards, according to Lenz's law, that has to be opposed. So to oppose south pole, you need again a south pole over here. South pole repels a south pole. So south pole means clockwise direction. So this will be clockwise direction. So this is our first one. Next, a uniform magnetic field exists in a region given by 3I plus 4J plus 5K. A rod of length 5 meters is placed along y-axis and it is moved along x-axis with a constant velocity 1 meter per second. Then the induced EMF in the rod is. So here all these are given in vector form. So induced EMF in vector form is B bar dot L bar cross V bar. This is the formula. So let us now see L bar. L bar is length. Length of the rod is along y-axis. So L bar is equals to 5 into y-axis is J cap. It is moving along x-axis with a constant speed. So velocity V bar is equals to 1 into I cap. So here L cross V. So cross product 5 into 1 is 5 into J cross I. I cross J is K. We need J cross I. It will be minus K. So this is minus K. Then now this one dot product of these two 3I plus 4J plus 5K and this 5. So this has to be dot product minus 25 volts. According to the options, if you go, it has to be the magnitude. So magnitude is 25 volts. Next, a small square loop of wire of side L is placed inside a large square loop of side capital L. Capital L is much greater than small l. These loops are coplanars and their centers coincide. Then what is the mutual inductance of the system? So let us take this one onto the next page. So there is a small loop of side L, small l, this one, which is placed coplanar inside another one, this one. This is capital L. So this is small l and this is capital L. Now say current is flowing through this wire. So this coil, sorry. So the bigger coil becomes our primary coil. So now current in this is in this direction. So field will be inwards. Field is inwards. And how do you find out the field? You can just take this wire, this coil, square coil, as the combination of 4 finite wires, and each wire makes an angle here. This total side is L, so perpendicular distance is L by 2. For square, this is 45, this is 45. So due to a finite wire, magnetic field at this point at a perpendicular distance is given by mu naught by 4 pi into I by R perpendicular into sin theta 1 plus sin theta 2. So let us now substitute. R perpendicular is L by 2, sin 45 1 by root 2, sin 45 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 by root 2, which is root 2. So this complete becomes root 2. This is due to one wire. Due to all these wires, the field gets added up because this is in a continuous one. So due to this one, the field is inwards. So hence the net field will be equals to 4 into mu naught by 4 pi into I by R perpendicular is L by 2 into this has already come out to be root 2. This is the magnetic field. Now flux associated will be equals to, I am taking magnitude B bar dot A bar, B bar into A bar. A is the minimum common area. That is nothing but the area, that is the area of this one. So its length is A. Area vector is outwards for this green colored coil. Area vector is outwards and field is inwards. So theta is 180, 180 cos 180 is minus 1. You get a minus over here, but we are finding out the magnitude. So this is equals to B. We already have this B. So according to the options, okay, 4 and 4 we can cancel over here. This is mu naught by pi into I by L into 2 root 2 into area. Area of the smaller coil is L square. So mu naught by pi, mu naught by pi, mu naught by pi, then I by capital L, I by capital L, I by capital L. I is missing over here. Okay, anyway, small L square by capital L square. So this one. He is asking mutual inductance, right? We have found out flux. Okay, but we know flux is equals to M into I. So compare these two equations. LHS is same. RHS, if you equate, in place of M, what do you get? M is equals to mu naught divided by pi into 2 root 2 small L square divided by capital L. This one. So flux is not asked. Coefficient of mutual induction is asked over here. So this will be the answer. Once check. Mu naught by pi, mu naught by pi, mu naught by pi. Okay. Mu naught by pi. 2 root 2 L square by L. This one. 2 root 2 L square by L. Okay. Then next one. The current in a coil changes from 0 to 2 amperes in 0.05 seconds. So change in current is 2 amperes and time is 0.05 seconds. Induced EMF is 80 volts. Then the self inductance of the coil is. So we know induced EMF is equals to L into di by dt. So induced EMF is 80 is equals to L into di. Di is 2 divided by dt is 5 into 10 to the power of minus 2. So this becomes 8 5 is 40, 400. 410 power minus 2 zeros goes off. So that is 4 is equals to L into 2 comes here. So implies this is 2 Henry. 2 Henry. Next. In an inductor of self-inductance 2 millihenry, current changes with the time according to the relation. So current is changing with the time according to the relation, this one. At what time the induced EMF is 0? So induced EMF, which is EMF which is induced in a self-inducting coil is L into di by dt. So it is given that induced EMF has to be 0. So for induced EMF to be 0, this di by dt also has to be 0. So what is that you are supposed to do now? Differentiate this I and equate it to 0. So let us differentiate. Di by dt is equals to, you apply UB formula here for differentiation. T square differentiation is 2t into this is as it is, e power, this one, plus now this is as it is, t square, chain rule you say, and iska differentiation e power minus 1, this. So now this has to be equated to 0. So 0 is equals to 2t e power minus t minus e power minus t t square. So from here this and this is sent to this side, 1t is also gone. So we get t is equals to 2 seconds. So after 2 seconds the induced EMF in the coil is 0. Next, sixth problem. A bar magnet of magnetic moment M is cut into 2 identical pieces along its length. So a bar magnet is cut along its length. So when you cut along its length, its magnetic moment will be M by 2. Its magnetic moment also will be M by 2. M by 2. 2 pieces you got. Now one piece is bent into the form of a semicircle. Now when a bar magnet, I am first writing the formula. When a bar magnet of magnetic moment M is bent into the form of an arc of a circle making an angle theta at the center, then the new magnetic moment M prime is equals to 2m sine theta divided by 2 divided by theta. Theta is to be taken in radians. So theta has to be should be taken in radians. So in that case, this is the arc of a circle. Here it is given semicircle. For semicircle, theta is 180 or pi. So pi by 2, sin pi by 2 is 1 and this is pi. Also, here original magnetic moment is m. M is bent into the form of a semicircle. But here one piece is bent into the form of a semicircle. That means m by 2 is bent. So therefore, now when this is bent, okay, when this one is bent, then our formula becomes 2. M is the initial magnetic moment before bending. So it is m by 2. Sin pi by 2 is 1 divided by pi. So this is m by pi. If two pieces are perpendicular to each other, then the resultant magnetic moment. Now these two, this one is as it is, this one is m by 2. The other one which is bent into the form of a semicircle like this. So iska magnetic moment is m by pi. Whatever be the poles over here, because it is perpendicular now, one of the magnetic moments will be like this, other magnetic moment will be either like this or like this. So both are perpendicular. So as a result, the net magnetic moment will be equals to root over a square plus b square. So m by 2 whole square plus m by pi whole square. M by pi whole square. So second option would be the answer. Next, seventh. Two magnets of magnetic moment, m and root 3m are joined to form a cross. So say this is m and this is root 3m. They are joined to form a cross. The combination is suspended freely in a uniform magnetic field in the equilibrium. So if you take this to be the direction of field, when this is suspended, this combination, say it is coming to equilibrium like this. This is m, this is root 3m. Then the angle between the magnetic moment m and the field is m and field, this one, theta. If this is theta, this would be 90 minus theta. Now equilibrium means the torque acting on m is equals to torque acting on root 3m. Torque acting ka formula, you know, couple acting on a bar magnet formula is mb sin theta. So for first one, couple C1 is equals to mb sin theta and C2 is equals to root 3mb into sine of 90 minus theta. Now in equilibrium, these two couples are equal. So when we equate, mb getting cancelled, sin theta is equals to root 3 into sin 90 minus theta is cos theta. Cos theta to this side, sin by cos is tan, tan theta is root 3, so theta is 60 degrees. Next, two magnets are placed one above the other with like poles together. So two bar magnets one above the other with like poles together, south and north, south and north. So both the magnetic moments are in same direction. So initial magnetic moment will be equals to m1 plus m2. The time period of this combination is 10 seconds. So 10 seconds. Now they are placed one above the other with unlike poles touching each other. So now final, m final is equals to unlike poles. Let us assume m1 is greater than m2. So m1 minus m2. Then the time period of the combination is 20 seconds. 20 seconds. The ratio of magnetic moments is. So time period ka formula is T is equals to 2 pi under root I by mb. So T and m are inversely proportional. So this is say initial and this is say final. So in inversely proportional. So if it is inversely proportional, we write it as mi by m final is equals to root over, just a minute. This one, T initial by T final is equals to root over inversely proportional m final divided by m initial. So this implies Ti, this is 10 by 20 is equals to root over final is m1 minus m2 divided by m1 plus m2. We are asked to find out the ratio of the magnetic moments m1 by m2. So this is 2 square on both sides and you just reciprocate this one. So this will be 4 by 1 is equals to m1 plus m2 divided by m1 plus m2. Now from here you either cross multiply and get the value of m1 by m2 or just apply componendo and dividendo. When you apply componendo and dividendo, you get m1 by m2 is equals to 4 plus 1, that is 5, by 4 minus 1, that is 3. So 5 is to 3. This is the answer, 8th one. Next, 9th. A magnet suspended in uniform magnetic field is heated so as to reduce its magnetic moment by 19%. So magnetic moment is reduced by 19%. So M2 is equals to 90% reduced. So 100 minus 19, it becomes 81. 81 by 100 of M1. This is how you write whenever there is a percentage increase or decrease. Final value is equals to 100 minus this percentage because it is given as by. So M1. By doing this, the period of magnet will decrease by, decrease or increase by. See, these are the options. So same again, time period. So time period is inversely proportional to square root of magnetic moment. Therefore, T2 by T1 is equals to under root M1 by M2. M1 by M2. M1 by M2 is cross multiply. M1 by M2 is, it will be 100 by 81 under root, which is 10 by 9. Now we want percentage. He is not asking final time period. He is asking the percentage increase or decrease. Always remember, percentage change is final value minus initial value divided by initial value into 100. But here you got final by initial. We need final minus initial by initial into 100. So for that, just subtract 1 on both sides and multiply with 100 on both sides. So it is T2 by T1 minus 1 into 100 is equals to 10 by 9 minus 1 into 100. So this happens to be T2 minus T1 by T1 into 100, which is nothing but the percentage change. And this will be 10 minus 9 is 1, 1 by 9 into 100. So this will be around how much percentage? You can just check. 11%, and it is, you are getting positive, so it is increase. So it increases by almost 11%. Just check once. Next, figure illustrates how B, the flux density inside a sample of unmagnetized, this is a sample of unmagnetized ferromagnetic material varies with B naught. The magnetic flux density in which the sample is kept. For the sample to be suitable for making permanent magnetic substance, what is given? So we know this is this one, coercivity and retentivity, these two. This one, it is retaining, so retentivity and coercivity. So in that case, for permanent magnet, both have to be high. So OQ and OR should be high, both should be high, that is large. So retentivity, this one, coercitivity. Next, 11th one. A current in the circuit is given by I is equals to 3 plus 4 sin omega t. Then the effective value of the current is, effective value in the sense RMS value. Now there are two methods you solve this one. One is the conventional method, you go according to the formula. Second one is the direct formula. So I will tell you the first one and second one both, but first one I am not going to solve. I am just telling you the method, how do you approach. So first thing, what is the formula for IRMS? RMS current ka formula is root of mean of squares of all the current, where average of I square is nothing but integration of I square dt divided by integration of dt from 0 to t, 0 to t. So the first method is, denominator anyways is t. Numerator, I ka expression whatever is there, 3 plus 4 sin omega t, you have to substitute here, you get a plus b whole square, a square plus b square plus 2ab, integrate the entire expression, divide it by t, whatever you get the answer, take the root. This is one method which is very lengthy, and generally NEET students cannot again go with the integration and all those things. So in that case, what do? There is a shortcut for this one. If current I is equals to a plus b sin omega t plus c sin cos whatever omega t 2 omega t whatever, then RMS current is equals to root of a square plus b square by 2 plus c square by 2 and so on. So if you apply the formula here, under root a square 3 square plus b square by 2, that is 4 square by 2. So this is root over 9 plus 16 by 2 is 8. So this will be root over 17. This is the answer. Next, 12th one. In LCR circuit, the voltage across the terminals of resistance, inductance and capacitance. This is voltage across resistance, voltage across inductance and voltage across capacitance, VC. Then the voltage across the main source will be, the formula is V is equals to root over VR square plus VL minus VC whole square. So just substitute and get the answer. VR square is 40 square plus VL minus VC, 60 minus 30 is 30 whole square, which is equals to 50 volts. Next, in a series LCR circuit, inductance L is 10 millihenry, capacitance is 1 microfarad and resistance is 100 ohms. Then the frequency at which resonance occurs is, resonant frequency is given by the formula 1 by 2 pi root over LC. So 1 by 2 pi root over L into C. L is this one, which is 10 to the power of minus 2. C is 10 to the power of minus 6. So this is 10 to the power of minus 8 under root. 10 to the power of minus 4 goes to the numerator. 10 to the power of 4 by 6.28. This one is 10 divided by 6.28 into 10 cube. 10 cube becomes kilohertz. So 10 by, so again, as I told you in my videos, previous videos, see the options. If they are far apart, approximate you can go. 10 by 6 is approximate 1 point something. So 1 point something may there are two options, but one is in terms of kilohertz. So therefore kilohertz. This one is the answer. Next, 14. The net impedance of the circuit will be impedance, net impedance. Pehle to formula, what is the formula for net impedance? Impedance is equals to under root R square plus XL minus XC whole square. So let us find out XL and XC separately. For that, XL is equals to omega L, 2 pi f into L. So this is 2 pi. F is given in the diagram as 50 hertz, you can check 50 hertz into L. L is this one, 50 by pi millihenry. 50 by pi millihenry. Milli is 10 to the power of minus 3. So pi and pi getting cancelled. This is 2500. 2500 into 2 is 5000 into 10 to the power of minus 3, which is equals to 5 ohms. This is XL. Go to XC. XC happens to be 1 by omega C. 1 by omega. Omega is 2 pi f 50 into C. Let us see what is capacitance. Capacitance is 10 power 3 by pi microfarad. 10 power 3 by pi. Micro is 10 to the power of minus 6. So check this one, this and this getting cancelled. This one is 100. 100 and this is 10 power 3, 10 power 5. 10 power 5, 10 power minus 6 is 10 power minus 1 goes to the numerator, it becomes 10. So XC is 10, XL is 5 and R is 10. So therefore this is equals to, Z is equals to root over 10 square plus XL minus XC, 5 minus 10 is minus 5 whole square. So this is 100 plus 25, 125 under root, which is 5 root 5 ohms. This is the net impedance in the circuit. Next, 15th one, the magnetic flux linked with the coil in Webers is given by the equation. This is the flux. Let us take down the equation, 3t square plus 4t plus 9. Then the magnitude is asked. Induced EMF is equals to minus of d phi by dt. But as magnitude is asked, we can directly take now, differentiate. D phi by dt is equals to 60 plus 4 at t equals to 2 seconds. So 6 into 2 plus 4, 12 plus 4, 16, which is fourth option. Next, 16th question. A rectangular loop has a sliding connector PQ of length L and resistance R ohms and R ohms. Its resistance is R and it is moving with a speed V. The setup is placed in a uniform magnetic field going into the plane. Here the field is into. Then the three currents I1, I2 and IR. So let us go with this one. Sorry. This is one resistance. This is the other resistance. Both the resistances are equal and there is a rod slider of again a resistance R PQ. And field here is inwards and it is moving like this with a velocity V. This is R, this is R. Now, when this rod is moving this way, EMF is induced in the rod. So this rod acts as a source of EMF. Source of EMF means it acts like a cell. Now, how do you get the polarities of the cell? By applying the right hand rule, Fleming's right hand rule. Forefinger points the direction of field, thumb points the direction of motion of the conductor, and then the central finger will point the direction of induced current. Induced current is this one. So this is induced current. And as I said, this is acting like a cell. Inside the cell, outside the cell, current flows from higher potential to positive to negative. Whereas inside the cell, the current flows from negative to positive. So this is negative and this is positive. Now this diagram, I draw it as first resistance this way. Then this rod will behave as a source of EMF with an internal resistance R. Source of EMF like this. And this one is also capital R. So R, R, R. And the induced EMF is BLV. As we know, BLV. So now you can check the current starts from here, total current I. And when it comes here, it gets divided. It means these two are in parallel. And in parallel combination, current gets divided in the ratio of inverse of the resistance. But as the resistances are equal, current also gets divided equally, I by 2 and I by 2. Like this. So if we are able to find out I by 2 will give you the current through these two. So how do you get I? I is nothing but total EMF, that is BLV, E effective divided by R effective. So E effective is BLV, R effective. These two are in parallel. R and R parallel, R by 2. That R by 2 and this R are in series. So R by 2 plus R, which is 3R by 2. So 3R divided by 2. So I ka value we got 2 BLV by 3R. 2 BLV by 3R. 2 BLV by 3R is this one. Only one option. So this has to be the answer. And if we need these currents, I1 and I2, I by 2, I by 2. Whatever you answer you got, just divide it by 2. So that will turn out to be BLV by 3R. BLV by 3R. I1 equals to I2 is equals to BLV by 3R. Next. A wheel with 10 metallic spokes, each of length 0.5 meter, is rotated with a speed of 120 revolutions per second in a plane normal to Earth's magnetic field. If the magnitude of the field is 4 Gauss, then the induced EMF between the axle and the rim of the wheel is. So this is nothing but a rod in a magnetic field rotating about one end. So in that case, induced EMF, how many ever spokes be there? The induced EMF will be half B L square omega only. Even if there are 10 spokes, 100 spokes, because all the spokes will be in parallel combination, and in parallel combination the effective EMF is same as that of the individual cell. So this is half B. B is given as 0.4 Gauss. So Gauss, 1 Gauss is 10 to the power of minus 4 Tesla. So this happens to be 4 into 10 to the power of minus 5 into L. L is 0.5 whole square. It will be 25 into 10 to the power of minus 2 into omega. Omega is, let us find out separately, 2 pi f. Frequency is the number of revolutions per second. It is given as minutes. So 120 revolutions divided by 60. So this is 2 times 2 to 4, 4 pi. 4 pi. Once check anyways here. So this one is 2 times. This is 50. And that will be 50 into 4. 50 into 4 will be 200 pi into 10 to the power of minus 7. So this is 2 pi. 2 pi is 6.28 into 10 to the power of minus 5. 10 to the power of minus 5 volts. So this. Next, 18th question. The wingspan of an aeroplane is 20 meters. So length is equals to 20 meters. It is flying in a field where the vertical component of magnetic field BV is equals to, these are the wings of the aeroplane and vertical component. So the field and the length are perpendicular. So 5 into 10 to the power of minus 5. Moving with a velocity 360 kmph, 360 into 5 by 18. This is 20, so this is 100. Then the potential difference produced between the blades is, so this is motional EMF and the rod is moving in a straight line, BLV, induced EMF. So B is 5 into 10 to the power of minus 5, L is 20 into this is 100. Once check over here. So this is 100, 100, 100, 10 power 4, 10 power 4, 10 power minus 5. It is 10 to the power of minus 1, which is 0.1. 0.1. It is first option. Next. The magnetic needle has a magnetic moment. This is M. And moment of inertia. This is moment of inertia. I think the calculations will be lengthy over here. It performs 10 oscillations in 6.7 seconds. So here, time taken for one oscillation is called as a time period. So how much is the time taken for 10 oscillations? For 10 oscillations, 6.7 seconds. For one oscillation, how much? 6.7 divided by 10. This will be the time period. What will be the magnitude of the magnetic field? So magnetic needle and this one. Therefore, we have the time period. T is equals to 2 pi root over I by MB. Now, we need B. So, squaring and cross multiplying. B is equals to 4 pi square I divided by M T square. So, this one 4 pi square approximately I am taking it as 10 into I, moment of inertia is given as 11.5 into 10 to the power of minus 6 divided by M. This is 8.7 into 10 to the power of minus 2 into T square. T square will be 0.67 into 0.67. This one. So this calculation is to be done. In that case, if we do the calculation, I am only taking the numbers, 10 powers, we can do it later. So 4 into 11.5 divided by 8.7 into 0.67 into 0.67, 11.77. So 11.77 into, now let us go with 10 powers. This is 10 power minus 5, 10 power minus 5, and this is 10 power. So this is 10 to the power of minus 3. So this will be equals to 0.0117. So 0.012. Check if there is any option. 0.012 approximately. So first option is the answer. Next, in an LCR circuit, an alternating voltage and current are given by this one and this one. So you can see the phase difference between voltage and current is pi by 3. The average power dissipated, average power का formula है IRMS into ERMS or VRMS, whatever, into cos phi. IRMS is I naught by root 2, ERMS is V naught by root 2 into cos phi, pi by 3, 61 by 2. So this would be I naught into V naught divided by 2 into 2, that is 4. Second option. Next, the RMS value of AC of 50 Hertz is 10 amperes. So RMS, IRMS is equals to 10 amperes. The time taken by AC in reaching from 0 to maximum. Yesterday's video, if you have seen, therein I have given you some shortcuts to, in case of oscillations, time taken by the body to go from y equals to 0 to y equals to a by 2, y equals to 0 to y equals to a by root 2. I said this is helpful in alternating currents also. So this is where you can just take. So this is I is equals to 0. 0 means mean position. I equals to I naught means extreme position. Time taken by a particle to go from mean position to extreme position is t by 4. T by 4. So t is 1 by f frequency. So frequency is 50. So this is 1 by 200. 1 by 2 is 0.5 into 10 to the power of minus 2, which is 5 into 10 to the power of minus 3 seconds. So 5 into 10 to the power of minus 3 seconds. And also we are asked to find out peak value of current. We know IRMS is equals to I naught by root 2. So I naught is equals to IRMS, that is 10 into root 2, which is 14.14. So therefore, the time taken is 5 into 10 to the power of minus 3 and peak value of current is 14.14. So yes, this is what. So this is what some important problems, not important, we cannot say these are important, but just to revise the formulae from these 3 chapters, frequently the common familiar formulae. Thank you then.